what's up guys? I got a lot of great questions on my Nest Wi-Fi router video, so I kind of want to explain how it works and how a router works and how devices connect to the internet and what it really means to be connected to Wi-Fi. So we're going to start with the Internet Service Provider, otherwise known as ISP. Now this is basically a company you pay a subscription fee and they give you cable modem, for example, or DSL, and there's different types of internet connections, but we're going to use a cable modem in our example. So you get your cable modem, and the cable modem connects to the internet. And the internet's really just a whole bunch of networks connected to each other, otherwise known as a WAN, a wide area network. But wide area network can mean a lot of things. I'm not going to go too much into definition of what a WAN actually means. Just know that the internet is basically a collection of networks connected together all over the globe. When the cable modem connects to the internet, it is assigned an IP address, an Internet Protocol address. Now, an IP address, think of it like a home address or like a phone number, something that should be unique, not guaranteed to be unique, but in most cases it should be unique. So an IP address looks something like this. So an IP address is basically like 104.18.27.118. Now, each one of these numbers can go from 0 to 255. You cannot see a 256 here, or here, or here, or here. So the range is between 0 to 255 in each one of these decimal spots. So from all of these, basically. This is what's known as IP version 4. So sometimes you might have seen this term. IP version 6, which exists in some countries, I believe Japan's using that. There are essentially two more numbers, so you're going to see another dot here with a number, and a dot here and another number. And that basically guarantees that every number will be unique. But essentially, think of an IP address kind of like either a home address or a phone number. And it's basically your gateway to the internet. That's who you are. So if we were to compare this to a phone number, so if my phone number was 1-800-123-456-789, then if I made a phone call from that number, that's the number that would be showing on the caller ID. And for someone to reach out to me, they would have to call that number. It's the same thing with an IP address. Just on a conceptual level, when you have an IP address, devices could connect to the internet. So if there is a laptop, and the laptop wanted to connect to the internet, well, that would be pretty simple. All you would have to do is basically run a connection between the laptop and the router. And this cable would be called an Ethernet cable. And there are different categories of Ethernet, but the most common ones are Cat5e and Cat6. And Cat is short for category, but essentially, these are basically saying the speeds of the cable. Sometimes an Ethernet cable is also known as a network cable. They all essentially mean the exact same thing. So in this case, you have one device, it's connected to the cable modem, and that's providing it internet access. So you're good to go, right? Well, the problem arises when you have more than one device, which most households do have. Let's say I had a desktop computer. And so now I want to connect both my laptop and my desktop to the internet. Well, the problem is the internet, the cable modem itself, which is this device, only has one Ethernet port and is only providing one IP address. So with one IP address, I can't connect two things at the same exact time. That's just not going to work. In order for me to connect this device, I would basically have to connect this to the cable modem, and in order for me to connect the desktop to the internet, I would basically have to delete that cable and run a new cable from here to here. Well, you could see how that can get tedious. The solution comes in the form of something known as a router. Okay, so in order to hook up both devices at the same time to the internet, I need something known as a router. So I specifically have the Nest Wi-Fi router, which is a mesh system. But we're just going to talk about a general router, and it applies to the Nest Wi-Fi router and pretty much any other router from a general standpoint. Obviously, there are differences between different routers, but conceptually, they pretty much all do the same thing. What a router does is it has something known as network address translation. Okay, so we have this IP address, and this is the IP address that No matter which device you use to connect to the internet, so as long as you're going through the cable modem, the internet will see us as this IP address. So if we are using the laptop or the desktop, both of them will have this IP address because this IP address is provided by your ISP. Here's where the magic happens. You get an Ethernet cable and you hook it up to your router, and we're going to write Ethernet. What your router does is it has a network address translation, and it takes this IP address and it converts it to multiple IP addresses. Through the network address translation, it actually assigns an IP address to this and an IP address to this. Now I'm going to use the most common one that I've seen with most routers. The Nest Wi-Fi router is very close to this number, but I'm going to use one that I've seen the most, which is 192.168.1.37, 192.168.1.45, and the router itself typically uses 192.168.1.1. Now, earlier I said that each one of these numbers has a range of 0 to 255. Well, the problem is 0 and 255 are actually reserved and you can't use it here. So, and because 1 is actually reserved for the router itself, otherwise known as the default gateway, so your valid range is actually between 2 to 254. So if you do the math, it comes out to 253 devices. Now, what does this mean? Okay, I want to explain this part clearly. If you noticed, I used 192.168.1.1 here, and I used the same number here. I also used the same number here. That was not by accident, that was intentional. Now, different routers have different numbers. This is a common one. But essentially, unless you change the subnet mask, which we're not going to get into because that's just going to complicate things, just pretend the first three numbers are not going to change. So, because they're not going to change, what the router did using the network address translation is actually assigned a unique IP address to both devices. Now, if you had another device, let's just say you had let's just say you had an Xbox and you wanted to connect to that, you can connect this to the router as well, and this will get assigned a number, and it'll be 192.168.1, and anything that's not used from 2 to 254. So I could just say 201. And again, I use the first three numbers are the same for anything within the same network. What the router actually did is it basically said, you're now unique, you're now unique, and you're now unique. So when the laptop is connected to the router, it comes in as this IP address. The router then changes this address to this address when it sends it off to the internet. And the cable modem is actually going through this address to the internet. So to the internet, this laptop has this IP address. This desktop has this IP address. And this Xbox has this IP address. But within your home, they're all actually unique. Now, why do they need to be unique? They need to be unique because each device needs to have a connection to each other or to the network. If you have two devices with the same, think of these like phone numbers. If we have two devices with the same phone number and we're trying to call one of the phones, what's going to happen if they're two different devices? Like, if I'm trying to reach this computer, how is that going to work? Or a better example is if we have a printer and I can't draw at all. So I'm just going to write printer. So if we have a printer and the printer is a network printer and it also connects to the router, and you guessed it, it gets its own IP address. So 192.168.1.54, something that's not in use currently. If this was the same exact number as, let's say, the Xbox, if this laptop was trying to print something, if I said, okay, print, and I know my printer is at this IP address, how does it know not to go to the Xbox to print? It might just send a message to the Xbox saying, hey, print this document. The Xbox is going to say, I don't know what to do with that. I don't know how to print. Therefore, IP addresses are important because this computer can now send print documents to the printer because it goes to this IP address. It needs a unique address even within the home to be able to talk to it. If this laptop wanted to share a file between the desktop, how would it know to talk to the desktop? Well, it needs to know based on this IP address. If this laptop wanted to connect to this desktop, it would basically just use this IP address, and vice versa, the desktop would use this IP address. So everything in the home needs its own unique IP address, and the router does that for you. Now, the router can do that one of two ways. You can either specify a static IP address permanently by typing it in the router, specifying in the settings of the router to say, hey, I want my laptop to be .37. I always want it to be .37. I never want it to change. Or the router actually has something called DHCP, which automatically assigns IP addresses. And you can even say like, okay, I want you to automatically assign IP addresses from this range. You could say .50 to .150. And so the DHCP will now, like, when 50 is available, it'll assign it 50. It'll assign it it automatically picks which one is available. Now, if the laptop was DHCP and it turned off, someone else can be assigned this IP address, and when the laptop turns on, it could change, if this one's being taken, it could get a different IP address. The important thing to know is you need unique IP addresses in the house. So that's basically what a router does. That's one of the things that it does. And by doing this, it lets devices in the house talk to each other. By talking to each other, I mean sharing files, printing to the printer. It does all of that, and it also lets them connect to the internet. And again, to the outside world, everyone sees you as this device, as this number, this IP address. And this is a sample IP address. Everyone's IP address is supposed to be different, although there are VPN services that all use the same IP address to hide someone's. It's one of the ways of hiding someone's presence by using the same exact IP address. But that's a discussion for another day. So hopefully that makes the things clear with the router and what a router is actually doing. So now I want to get into a mesh system. One thing I should mention is this could be an Ethernet cable or it could be through Wi-Fi, because your router is actually giving you your Wi-Fi capability. So if you wanted to connect the laptop wirelessly, the router would support that. So these are essentially either Ethernet connections or through a wireless connection. So the router obviously does both. And it doesn't matter if you wirelessly connect or wirely connected, you still get assigned unique IP addresses, and all devices can still talk to each other, whether they are wired or not. So as long as they're all connected to the same router on the same network. And another important distinction is that if you're connected to Wi-Fi to the router, it doesn't guarantee that you'll have internet, because you have to remember your cable modem is providing the internet, not the router. The router is just basically a means of talking to the cable modem. So if this part was down, you wouldn't get internet access. Even if you were connected to Wi-Fi and you had full strong bars, that doesn't guarantee you'll have internet. The only way you'll have internet is if your cable modem or your DSL or whatever you use to connect to the internet is up and running. So your Wi-Fi signal is actually just connecting to your router. What your Wi-Fi signal actually indicates is whoever's connected to your router, you can talk to them. So even if the internet's down, you could still send a request to do a print. These guys could do file sharing. Pretty much all your devices at your house can talk to each other as long as they're hooked up to the same network. And a network inside a home is called a local area network, otherwise known as a LAN. So hopefully that clears some things up. So just because you have Wi-Fi and you have strong bars and you have full signals doesn't actually mean you're guaranteed internet access, because internet access is totally dependent on your cable modem. Okay, so now that I've explained the router, here's where the mesh system comes into play. Okay, so these three devices are connected straight through Ethernet cable, and the laptop is wirelessly connected. The problem is, and again, no matter if you're wirelessly connected or hardwired, you get assigned a unique IP address. The router manages all of that for you. It does it all automatically. You don't have to worry about any of that. You could override some settings, but if you just put everything on auto detect, which it's on by default, the router will handle everything for you. The problem is, if you have your laptop and if you're closer, the bars are going to be stronger. But the farther away, the bars are going to get weaker and weaker. Here's where the mesh system comes into play. With the mesh system, you can start adding things known as access points. So I can put something here. It's an access point. So Google's router is called the Nest Wi-Fi router, and Google's access point is called the Nest Wi-Fi point. Now you can have multiple access points. The advantage of putting an access point, so we'll put another access point here. We'll call this one AP for access point. So what an access point does is it either connects through an Ethernet cable or wirelessly to the main router. You have a dedicated connection. These wires could be Ethernet or it could be wirelessly connected. In most cases, they're actually wirelessly connected, but it doesn't really matter. I just want to show that there's a connection there. And actually, the access points also get their own unique IP addresses, but for the sake of argument, we're just going to kind of like skip that because that's not super important at this particular second. Because you put an access point, the problem was the farther you got away from the farther the laptop got away from the router, the weaker the signal became, to a point that if the signal gets super low, you're going to have either slow internet on the laptop, it's going to be slow to do file transfers, it's going to be slow to send a request to the printer, it's going to be slow to have internet access, it's going to be slow to have everything. Okay, so now that we have an access point, I'm going to delete this line. What your laptop is actually going to do is, if you're walking around your house and your laptop is closer to this access point, it's going to connect to this guy. If you're walking around your house and you take your laptop all the way to this side, it's going to connect to this access point. What that means is if you connect in this particular case, because it's close to this access point, it's not going to try to connect to this router. It's going to try to connect to this access point instead. Translation, you're going to get full bars. And you're going to have a very strong connection between the laptop and the access point. And you'll still get your own unique IP address, and it may stay the same, it may change, but usually it tends to stay the same. Now you're thinking, okay, well, if I have a strong Wi-Fi signal to the access point, if the laptop is connected to the access point, does that mean I'll have fast internet? Well, it depends, because now the access point is really a middleman. Because now, instead of going directly to the router, then to the cable modem, then to the internet, now you're going to the access point, to the router, then to the cable, then to the internet. Even if you have a relatively strong connection to your access point, doesn't necessarily mean you're going to get the fastest speeds. Now, if your access point is hooked up through Ethernet, you're almost guaranteed to get the fastest speeds. Like, it wouldn't really matter if you connected to the access point or the router. You're pretty close to being guaranteed that you're going to get the same exact speeds. So it heavily depends on this connection. Now, the farther away your access point is from your router, the weaker your access point signal is going to be, because your access point pretty much kind of has something similar, where the farther away you get from your router, the weaker it gets, unless it's connected through Ethernet. If this connection is through Ethernet, then you're going to have a strong signal. Then this doesn't matter at all because you're hardwired. But if it's a wireless connection, then you have to strategically place the access point and to see if it's, if it's connected. Now, what you want to do is you want to put the router kind of as the center, as the midpoint. If you have one router and one access point, that doesn't really matter. But if you have multiple access points, you want the router to be the center. The reason why you want the router in the center is because you want all access points to talk to the router directly. If you put another access point, let's just say like somewhere in the backyard or something like that, because it's too far away from the router, it actually will automatically connect to this access point, then it'll go to this access point. The problem is that this one will have a slower connection because it's going from one access point to another and then to the main router. So when an access point connects to another access point and then to another access point, the connection is basically halved, but essentially it's just slowed down. You kind of don't want this. If you can avoid it, you kind of don't want this. You want all access points to talk directly to the router to ensure the fastest connection, because in this particular case, these two will be fast and this one will be slow compared to these two. And when I say slow, I mean if you take your laptop and you're on this side and you connect to this access point, your internet's going to suffer more, your network's going to suffer more. There are other things to know like dual band, tri-band. There are different frequencies. They give you less, like tri-band gives you less congestion and stuff. There's a lot of like little things like that I can explain, but I kind of want to keep this at a general level and just kind of show you why people would consider a mesh system. Because if you're far away from the main router and you're on Wi-Fi, you may want to consider a mesh system to connect to a closer access point. But if this is wirelessly connected to this, again, you're not going to get the best speeds. You might get really good speeds, and depending on how fast your internet is, the faster the internet, the more of a speed drop you will notice when you connect to an access point versus a router, if this is wireless. So hopefully that part makes sense. One more important thing to mention is a switch. Now, what is a switch? So earlier I was connecting the router to the desktop, to the printer, and to another desktop or an Xbox. And I was just connecting it with saying I was connecting with Ethernet. Well, what happens if you don't have enough Ethernet ports from the router? Now, this is not a problem for wireless devices like a laptop because they'll connect to the access point or to the router through wireless. But if you want a physical hardwire connection and your router doesn't have enough ports for all the devices, how do you do it? Well, the answer is simple. You just need a switch. A switch, there are a few basic kinds. I'm going to draw one with 4 ports. That's a simple one. There are 2 types of switches, unmanaged switches and managed switches. For most home networks, all you need is an unmanaged switch. The difference between an unmanaged switch and a managed switch, the managed switch lets you control extra things like priority and a lot of other settings, but you don't really need that because the router is doing all of that for you. All you really need for most homes is an unmanaged switch. Instead of hooking up the Ethernet from the router to the computer directly, all you do is you hook up the Ethernet cable from the router to the switch. Now this takes up a port, obviously, but you still have 3 left. So you could now run this here, run this to the printer, and run this to another computer or another device. If you need more, there are bigger switches with more ports. So there are 8-port switches, 16-port switches, 32-port switches, and so on. And you can also connect a switch to another switch. So if you wanted to have another switch in another room, let's say this was a switch in another room, and this one had 4 ports as well. And when I say ports, these are Ethernet ports. So instead of hooking up to the desktop, you can actually hook it up to this. So another Ethernet cable, and all these green lines are all Ethernet cables, which also takes up a port here. But then you can hook this up to a desktop, and now you have 2 additional ports that you can hook up to other devices. Now, when you hook it up to the unmanaged switch, you literally, it's plug and play. You literally plug it and you power on the switch, and the router handles everything. So the router is essentially managing everything for you within your home network. And in many cases, all you need is one router for your home, and it will handle all the network traffic, and it will handle all your devices and everything. As always, if you guys like this video, please like and subscribe. If you have any questions, write them in the comment section below. And thank you guys for watching, and I also want to thank all my current subscribers.